So I recently updated this viewport information tool with Wedges to the last version of Houdini, which is 19.5. And I also fixed some bugs and added some interesting features and made it more user-friendly. In this video, I'm going through the whole HDA, starting from the basic installation to the advanced use of wedges. So let's get to it. Once you have the file downloaded, you will see three items inside. The first one has the HDA, the second one the scripts, and the third one is the XML parameter menu. The par menu will add some options every time you right-click on in a parameter on Houdini, and these options will run the menu text and menu wedges scripts. And then inside this folder, you're going to find the main script, which is connected to the HDA Python module. So this is the XML. This is the main script, which is very huge. Here you have the menu text script and the menu wedges. Finally, we just have to copy all the elements here inside our Houdini folder. And now we can open a new session of Houdini to test the scripts and the tool. Let's check if the tool and scripts are working. So the name of the node is called Info, and you're going to find it inside the OBJ context. So call for the node. If there isn't any camera in this scene already, it's going to ask you to create a new one. As you can see, we have some information on the camera. And if we move the camera, this information is going to stick on the bottom left part of the display. So finally, we can check the parameter new options. So you can just create a new geometry node and go to any parameter, and you will find new couple of options here. You can send any parameter information to the display, and you can also make wedges. The tool is working fine, so let's start the tutorial on how to use it. In this scene, I have multiple cameras with different aspect ratios. I'm going to call for an info node, and then I can choose which one of the cameras I'm going to use. I'm going to start with the first one. The camera path is going to set on this parameter. Below, I have this parameter which shows the date and the time, the camera properties, the text, where I can add more text. And then I can move the position of the text on the display using these sliders. If I change the camera to, for example, the third one, the boundaries will be different. But this is not a problem, because when you change the camera, it's going to compute the boundaries automatically for you. If you change the font size here, now we can exceed the boundaries. When that happens, we can press Fix Bound button here to compute the new limits. If somehow the text is still outside the screen, you're not gonna be allowed to create images using this HDA. So some other important basic parameters you can play with are the font type, the horizontal alignment, the color, and the distance to camera. I usually set this distance to camera to the default value, unless the object is really, really close to the camera and it's overlapping the text. If you have a static camera and static parameters, you may want to deactivate this toggle here, but be aware of if you set this off, you're not going to see the frame range moving. And it's also important to be aware of the near clipping value on your camera, because if it's too big, it will call the text. Fortunately, the HDA will alert you if that happens, as you can see here. Now, let's save this scene and check the Flipbook creation feature. I'm going to create a test folder to save this scene. It's important to save your scene somewhere before using the tool, because otherwise it might create files in some undesired place of your OS. So the scene file is saved now, and the next step should be to decide where are we going to save the geometry or movies we create. As you can see on the top of the parameter network, we can choose to save all this in job variable. If we don't have the job variable set, we can do it using this button here. Or we can change it to $heap variable. Or we can use a custom folder. So in this case, I'm gonna save all the files in this custom folder here. So then I can go to Flipbook tab, and if you are gonna do a flipbook, you can only use the frame range option. You can change all these OpenGL settings, which are directly linked to the ROP network, OpenGL flipbook here. And just before creating the flipbook, we want to specify a movie name. In this case, I'm gonna call this track. So now we can create the flipbook. Now, if you take a look at the folder, inside you're gonna find this preview folder. And here I can see the movie name, which has the heap name and the element name, which is crack. And there you go. It's also important to be aware of the resolution you have on the camera. Sometimes when you import cameras, the resolution values can be uneven. If that's the case, you're not going to be able to do flipbooks or wedges. It's also mandatory that you have specified an element name. Now let's jump into the Wedges tab, and I'm going to show you how to use all these options. But before, I have to make sure you understand the logic behind the HDA. So let's talk a little bit what are wedges in Houdini and what this tool is capable of. Basically, wedges in Houdini are a way to get different outputs from a value or multiple values of a parameter. The final output can be either a mosaic video or a cache geometry. The maximum number of values I can choose from a parameter, if we want a mosaic, are 4. This will result in a 2x2 flipbook video mosaic. If we are targeting just one parameter and using staggered values, wedges, the 2x2 mosaic will show the output of the first value, the last value, and the two values in between. We can also do the same using two parameters, but in this case, the output will show the first and the last value of one parameter and the first and the last value of the other parameter. Then we can also go for many parameters as we want, but we'll have to toggle the random option on the wedges, which is here. And remember, we have to set the frame range to at least 2 frames in order to make a video. We can also set the wedges display prefix and the parameter display prefix to display on the screen. And if we are adding multiple parameters and wedges all together, we can sort it nicely using this arrange button. Let's try to create our first mosaic video. I'm going to show you the entire process and how the images are created and deleted in our folders. Let's now create our first wedges mosaic video. I'm going to let these 3 options here as default because we're not doing a simulation and I don't want to save any geometry. The wedges parameters are going to be shown down here, but you can add more using this only by right-click wedge option on a parameter. In this case, I'm going to start by computing 4 different wedges of one parameter. So let's, for example, get the uniform scale here and set the value to 1. Let's go back to the viewport info, and that's it. We can simply click the render wedges, and I'm going to show you what is this going to do on our folder. So as you can see, a new folder called temp images is created, and inside we're going to have the name of the file, the heap name, sorry, and all these folders with all the flipbooks with different values. The folder name can also be specified here in this wedge folder prefix, but since this is going to be deleted afterwards, it makes no sense. As you can see, the temporary images folder and the mosaic folder are already deleted. So let's get the preview of what we have. So you can see here we have this 1x4 or 2x2 mosaic of one parameter with different scale values. So now we're going to see the other options, starting with the 2 parameters and then going to multiple parameters on a random style. Right now, I'm using the uniform scale to create 4 different wedges, starting from 0.5 to 2. If I add another parameter, for example, the rotation, I'm going to get this pop-up error. And what it's saying is you can only do 4 wedges on 1 parameter or 2 wedges on 2 parameters. If this is not what we want, we can just simply click OK. Or we can click here, set 2 wedges, set the values, and you can see now the number of wedges has reduced, but now we are not allowed to add more wedges unless we go to random. Let's take a look how it looks now. So be aware that if you don't change neither the element name or you save a file with a different name, it's going to overlap or overwrite the previous video. As you can see now, we have the scale going from 0.5 to 2 and the rotation going from 0 to 180. Now let's switch to random samples to get more parameters. Once you switch to random samples, you can change the random shift if you want to get different values between the first and the last value of each parameter. And you can also add more parameters here and no error will pop up. I'm going to add a lot of parameters because I want to show you I can remove them as well from the wedges. You can also go to the Info tab and check this off. Now, every time you add the parameter, you will only have the name of the parameter. For example, let's, I don't know, this one. As you can see, this is now a little bit confusing because we've merged our wedges with the parameters. So just click the arrange text. And maybe I'm gonna adjust the font size a little bit. Click fix bounds. Then go to the wedges tab. And let's see what we get from here. Now, the new movie is overriding the previous one. And you can see all the random values we have on each wedge and the output. If we don't want to use some of these parameters, we can just delete it from here. For example, if I want to delete the X translate, I can click this button here. And the wedge is going to be removed from the list of wedges as well as from the display. If you have to delete some parameter, which is not on the list of the wedges, you can do it from the text. Now let's see what happens if we set the write cache option on. We can now see we have new different options to play with, which is the SOP path. Without this, you're not gonna be allowed to render any wedge. So you have to specify a SOP path. In this case, I'm gonna cache directly the crack geometry, then the extension. And this is also an interesting parameter to drive into the display. You might be wondering in which case we need to write the cache and then delete the cache. Well, this is useful on simulations due to the logic of the ROP network. If we dive inside the HDA, you can see that we have two options. The first one is to directly write the Flipbook JPEG, and the other option is to write the geometry. If we are doing simulations, we would rather want to write the geometry and then to create the flipbooks. But normally we want to keep the cache. I have saved a new version, so this is not gonna overwrite the previous movie. I'm gonna arrange the text, and then let's see what happens when we create the new wedge patch. As you can see, first it's starting to write geometry, then the temporary images, the mosaic, and then the video. And now, as you can see, it's deleting everything but the cache. We can check the video here. But also, an interesting feature is if we go back to the scene, we have this new geometry here, and inside automatically is loading all of our caches. And inside, if you go to the detail, you can see all of our attributes saved in this geometry. So now let's talk a little bit about the logic behind the ROP setup of this HDA and why I think it's better to cache the simulation when we are doing wedges. If I don't set the write cache option on, then the simulation will run, and at each frame, the setup will have the RAM memory busy with the simulation cache, while it runs an OpenGL to get a frame snapshot for the flipbook, and so on and so forth for the following frames. Instead, I believe it's way better and reliable if we first cache the output coming from the simulation, preferably with the cache memory parameter turned off. And then the HDA will create a temporary cache, file cache shop, loading the simulation just for the OpenGL. I'm going to show you how this works on every wedge. So if we dive inside my HDA, we can go to the ROP network, and this is the place where we can switch between these two options. This command, it will run a file cache shop, which is going to load all our cache geometry before doing the OpenGL. So if I turn this off and I run this shell, I can check that it has created my temporary geo. And then it has written the flipbook images for each wedge. And then if we had run the whole sequence, we could have created a mosaic and then the video and then deleted all of these temporary files. However, since we have run this shell node only and toggle this off, if I go to the SOP network, object network, sorry, I can see this temporary file which is loading the geometry for each wedge, meaning that it's going to use this very geometry to run every flipbook. instead of doing all the processes at the same time. This geometry is being deleted after the flipbook creation for each wedge, so the only purpose of this is to help the OpenGL to run faster. Lastly, another cool feature of this HDA is the possibility of disabling the mosaic creation and focusing on getting a cache of something we want to have some variations on. In this example, I'm not sure how to fracture this geometry, or maybe I want to avoid artifacts or fracture the geometry in many ways and merge all the outputs to run a simulation afterwards. So to do so, I will go to the create mosaic video, toggle this off, and we want to keep the write cache and keep cache on. Then we don't need more than one frame, so switch this to single frame. Also, you will notice that when you turn this off, you're allowed to increase the number of wedges. So let's set this to 20, and I'm going to have variations of all these parameters here. We have to specify the SOPS path of the geometry we want to write, and that's it. Let's render this. As you can see, all the wedges are done now. So if we jump back to our scene, we can go to this new object node, and we can see all the wedges here. Remember that you can also track all the attributes in the detail tab, so you can have an idea which values are being used on each wedge. For example, this is a value we want to avoid because these values are doing some artifacts on our fracture.